Hello everybody, this is Jared Taylor from the Biology 112 teaching team here at UBC, and in this video I would like to introduce you to, or perhaps remind you of, the topic of electronegativity. Remember in the last video how I said that chemistry concepts are important in Biology 112? Well, here we go. Let's do this. So, what do we mean when we say electronegativity? Well, electronegativity is defined as the relative ability of an atom to attract electrons in a shared bond. Now, when we say relative, what we mean is that electronegativity is a qualitative parameter that is used to compare any two atoms. In terms of trends, electronegativity varies across elements, increasing as we move up the periodic table and to the right. Each element in the periodic table is assigned a relative electronegativity number that ranges from francium in the lower left of the table, with an electronegativity value somewhere between 0.7 and 0.8, to fluorine in the top right, with an approximate electronegativity value of 4, the highest of all the elements. Note that the noble gases are not assigned electronegativity values because they usually do not form bonds. Looking again at the periodic table, in Biology 112, thankfully, we are only really concerned with 6 elements: hydrogen, carbon, nitrogen, oxygen, phosphorus, and sulfur. Okay, great. Electronegativity values, blah, blah, blah. So what? Well, understanding electronegativity is actually very useful in Biology 112 because it allows us to evaluate the types of bonds in a molecule. As an example, let's consider 2 atoms. Each atom has an electronegativity value, and they are forming a covalent bond. If the 2 electronegativity values are similar, the electrons in the bond will be more or less equally shared. This is what we refer to as a nonpolar bond. But what if the difference in electronegativity increases? Now one of the atoms is able to attract the electrons in the bond towards itself. Since the electrons are negatively charged, this gives that atom a partial negative charge, and the other atom a partial positive charge. In other words, permanent poles with partial charges are established between the atoms, and as such we call this type of covalent bond a polar bond. Finally, what happens if the electronegativity difference becomes extreme? Well, in this case, one atom rips the electrons away from the other atom, which means there isn't any covalent bond at all. In this case, the 2 atoms form a full negative or positive charge and attract each other strongly. This is what we call an ionic bond, although, as you will see later on, we often call this an ionic interaction. Okay, with all that in mind, how do we then use electronegativity in practice? No sweat, it is actually really straightforward. For any 2 atoms, you simply subtract one of the electronegativity values from the other and take the absolute value to keep the number positive. The magnitude of this difference in electronegativity can then be evaluated. The general rule of thumb is as follows. If the electronegativity difference is between 0 and 0.4, the bond is considered nonpolar. If the electronegativity difference is between 0.4 and 2, the bond is considered polar. Finally, if the electronegativity difference is greater than 2, the bond is considered ionic. As I said, these values are just a rule of thumb. There is some variability in this spectrum depending on the environment the atoms are in. For example, ionic bonds can form with differences in electronegativity as low as 1.7. However, for us here in Biology 112, the values shown here will work just fine. And in fact, you won't really have to do this calculation all that often. This rule of thumb will help you at first, but eventually you should be able to remember the type of bond you are looking at, especially since we only deal with a small number of atom types in this class. For example, you will quickly start to recognize that carbon-hydrogen and carbon-carbon bonds are nonpolar. Likewise, you will often see oxygen-hydrogen, carbon-oxygen, and nitrogen-hydrogen as typical examples of polar bonds. And finally, ionic bonds are easy to spot because they involve atoms with full positive or negative charges. So, I hope that gives you some insight, or perhaps some review, as to what electronegativity is. And trust me, you will get lots of practice using these principles in our course. In the next video I will talk more about why being able to quickly identify the types of bonds in molecules is a useful skill in Biology 112.